We are continuing to add properties to our logarithmic functions. So far we've learned the basic properties, we've learned the product rule property, and now we are going to learn the quotient rule property. The quotient rule property follows just the same as the product rule property, except for if we have a division inside our log function, that's going to change to a subtraction. And we're going to go through the proof of this. The proof of this is very much similar to the product rule property. So let's make a substitution. Let's m equal the log base b of x, and then n be the log base b of y. If I rewrite those in exponential format, that gives me b to the m is equal to x, and b to the n is equal to y. If we take x divided by y, that gives me b to the m divided by b to the n, and then I get to use my exponential rules that we learned quite some time ago, and that becomes b to the m minus n. So if I were to take log of this, that would be equivalent to log of this. So log base b of x over y is equal to log base b of b to the m minus n. Well, here everything cancels out, and that gives me m minus n. If I make the substitution of m minus n, that gives me log base b of x minus log base b of y. And we've just proved our quotient rule property. Log base b of x over y is equivalent to, in a couple of steps over here, log base b of x minus log base b of y. Okay, so that's the official proof, but let's go ahead and see it in this example down here. I have a log of 1 million divided by 100. The first direction that I'm going to take is I'm going to simplify the inside and then work it that way. The second direction that I'm going to take is I'm going to utilize this quotient rule, and I'm going to work it a different direction. Then I'm going to show that the answers to both directions are going to give me the same value, which confirms that this property works. Okay, so let me do my first direction where I simplify the inside. 1 million divided by 100, I can cancel out 2 zeros of both of those, leaving me with 10,000 on the top. So I have log of 10,000. And then if I want to simplify this, I can think about the exponential format. Well, there's no base here, so this is considered to be base 10. 10 to what power gives me 10,000? Well, I have 1, 2, 3, 4 zeros here, so that gives me 10 to the 4th power is equal to 10,000. So working this to the left-hand side gives me the answer of 4. Let's see what I get when I work at the right-hand side. Okay, well, if I rewrite this, this gives me log of 1 million minus log of 100. Again, both of these are base 10. They're the common log. And so if I were to write them into its simplified format, 10 to what power gives me a million? That gives me 10 to the 6th power. Minus 10 to what power gives me 100? That gives me 10 squared. And, of course, that gives me 6 minus 2. 6 minus 2 is equivalent to 4. So we just have confirmed that working this example, both directions gives me the same answer. So that just confirms that my quotient rule holds true. So we've seen what it is. Now let's actually utilize it to our best of our ability. Same as in the last video when we were doing the product rule property, we want to take single logs and expand them into separate logs. That's what we're doing in example 1 and 2 up top. And then in the bottom, taking separate logs, and we're going to combine them together into a single log. I have the property up here on the right. I suggest that you pause the video and see if you can use it in the correct format. Okay, in the first one, this is going to be log base 2 of c minus log base 2 of d. So basically, I just changed the division inside my logarithm to a subtraction in between two separate logarithms. Since all of these are variables here, I cannot do anything to simplify, so that's all we are expected to do at that point. In example 2, that gives me natural log of e minus natural log of 12. And since we know that natural log is base e, then this first one simplifies just to be 1. Natural log base e of e all cancels out, leaves me with the exponent of 1, and so that leaves me with 1 minus the natural log of 12. Now again, we can type in natural log of 12 into our calculator and get a very ugly decimal, but we don't like such things, and so we want to leave it in its exact format, and so the answer that we would hand in here is 1 minus the natural log of 12. Down here, express this as a single logarithm. So I see a subtraction between two logs with the same basis, and I'm going to rewrite it as a division. So this gives me log base b of 64 divided by 16. And I can simplify 64 divided by 6. And so the simplified version of this is log base b of 4. If I knew what b represented, I possibly could simplify it even farther, but I do not, and so this here is my final answer of that. So this suffices what we know about the quotient rule property. In the next video, we're going to be learning our last new property, and then after that, we'll be combining all of our properties together.